Hi, I'm Dr. Bill Carlizon, Principal Editor of NPP Digital Psychiatry and Neuroscience. Welcome to the DPN Deep Dive, our journal's AI-generated podcast that summarizes DPN articles in short, accessible episodes. Each episode is approved by the authors and designed to make listening easy and fun. Let's dive into this episode to explore the latest research in digital psychiatry and neuroscience.
Imagine for a second that you're a teenager. And it's not just that you're sad. It's that you feel nothing. The video games you used to love, hanging out with friends, even sports, it all just feels gray.
That's a perfect description of anhedonia. It's this profound loss of interest or pleasure, and it is notoriously difficult to treat in adolescence.
So what's the typical approach?
Well, one of the main therapies is called behavioral activation. The idea is, pretty straightforward. If you can just get the patient to start doing things again, especially things that used to be rewarding, it can kind of jumpstart their mood.
So almost like a fake it till you make it kind of thing, but with a therapist's help.
Exactly. But here's the problem. There's this huge blind spot. We call it the black box between therapy sessions.
Yeah, they're 167 hours of the week.
Right. What is the teen actually doing? Are they getting out, or are they just saying they are?
And I'm guessing asking a teenager, so what'd you do this week, doesn't always give you the most reliable data?
Not at all. Memory gets fuzzy, filling out logs is a pain, so therapists are basically flying blind. And that's the exact problem that researchers at McLean Hospital and Harvard Medical School decided to tackle.
And they published a paper with quite the title. It's Measuring Activation During Behavioral Activation Therapy, a proof-of-concept study using smartphone sensors and LLM-derived ratings in adolescents with anhedonia.
It's a real mouthful, yeah. But the core idea was, can we use the supercomputer that every teen already has in their pocket to measure this activation objectively?
Okay, so walk me through how they did it. How do you track doing things without being, creepy?
So they followed 38 adolescents over a 12-week therapy program, and they had two main methods. The first was passive sensing.
Passive sensing?
Yeah, for a smaller group, they used the phone's own sensors, GPS, and the accelerometer to just track movement. Where the phone went, how much it moved. The teen didn't have to do anything.
Okay, and the second method, that involved AI, right?
It did, specifically GPT-4o. The teens also wrote these short daily diaries in their own words about what they did that day.
Just free text entries.
Yep. And instead of a person reading through all of them, they fed the text to the large language model and just asked it to rate the level of behavioral activation. The AI's ratings lined up very well with the teen's own self-reported moods, but the GPS data, that revealed something even more interesting.
Oh, what did the sensors pick up?
Well, you might think that traveling a long distance like going on a big trip would mean someone is more activated.
Right, that makes sense.
But the data showed that distance didn't matter at all. What mattered was visiting more distinct places and, critically, spending less time at home.
So it's not about the quality of the distance, but the quantity of locations.
Precisely. But here's the real insight, the aha moment of the whole study. The data was most powerful when it was analyzed within person.
Within person, what does that mean? You're not comparing them to some national average.
You're not even comparing them to the other kids in the study. See, it doesn't matter if one teen is a homebody and another is always out. What matters is if that homebody starts leaving the house more often than their own usual baseline.
So you're only competing against yourself.
That's the metric that counts. If a kid who normally spends 95% of their time at home drops that to 85%, that's a huge clinical victory.
That seems like a massive shift in how we think about this. We usually have these, rigid benchmarks for what healthy is supposed to look like.
And this suggests those might be wrong. A personalized baseline is way more valuable. In fact, that passive data, that time at home number, it could actually predict if their symptoms would improve the following week.
Wow. So a therapist could potentially get an alert. They wouldn't have to wait for the next session to find out their patient is struggling.
It could make therapy proactive instead of reactive, but, and this is a big but, we have to be really clear, this was a proof of concept study. The passive sensing group was tiny, only 13 kids.
So it shows it's possible, but it's not ready for prime time.
Exactly. It needs to be replicated in much, much larger groups before you could ever use it as a real medical tool.
Still, the potential is fascinating. The idea that your phone could be an objective member of your care team. just quietly collecting data to help you get better.
It shines a light into that black box. And for a condition like anhedonia, where motivation is the very first thing to disappear, having an objective sign of progress, that could be incredibly powerful.
Thanks for listening to the DPN Deep Dive. Until next time.